Hello. In this video, we're going to go over implicit differentiation. We're going to go over deriving what happens when x and y happen to be on the same side or being multiplied to one another. Most of the time in the past, when we are finding derivatives of a function, we have a y equals in terms of x, and then we would find y prime in terms of x. In this situation, what we have is y and the x's mingled together. So what we do is we derive x normally, everything the same, just like we do. But when every time I derive a y, I must put a dy dx or a y prime. What we're going to do is a dy dx. Okay. Every time we derive a y. Please don't make fun of my spelling if it's misspelled. Next, let's jump straight into it, shall we? Number 5. What we're going to do is rewrite the equation because that's just good for memorization purposes and just organization skills. We rewrite the equation and we're going to slowly go through deriving it. First, I derive that first term. We're going to derive left to right all the way through. So we start on the left side of the equation, we derive it, and we see its normal power rule that 3 gets multiplied to the 5, and we subtract 1. Normal power rule. That's it. Next, what you're going to see is I have, well, what's that? I have a product rule between x and y. A little weird, but we'll go through it. Remember, if we recall product rule, f times g, what happens is we have f prime times g plus normal f times g prime. So derive the first one, keep the second one the same, keep the first one the same, derive the second one, and add them together. So we're going to do that here. What we see is I'm going to put parentheses, negative 3x and y. So we're going to derive the first one. The derivative of negative 3x is negative 3. And keep the second one, y. Next, we're going to keep the first one, negative 3x, derive the second one. Well, what is the derivative of y? Well, if it was just the derivative of x, it would just be 1. So the derivative of y would also be 1. However, every time I derive a y, I need to put a dy dx. And we will put that right there, just like that. And then plus 2, we know that that will go to 0. Perfect. So then we keep going. We're going to clean up now. 15x squared equals negative 3y minus 3x dy dx. Now, what if you're asking, well, what's the goal of this situation? We want to get dy dx completely by itself. That's it. So we're going to add the 3y to the other side. 15x squared plus 3y is equal to negative 3x dy dx. We'll divide by the negative 3 to both sides. Well, negative 3x, sorry, divided by negative 3x to both sides. We'll simplify the negative 3, 5x squared plus y, all over negative x. And that is what dy dx is equal to. And that's what we're solving for. Dy dx is the definition of well, be careful when we say definition because we're not using the actual definition of derivative, but this is how we represent our derivative of the function dy dx. And thus, this is how we implicitly derive. Let's do one more. And we will go over more complicated implicit differentiations in another video. So let's go over number 6. Rewrite the equation, please. And we're going to just jump straight into it. Deriving the left side, we get a 0. Deriving 3x, we get a 3. Now we have our product rule like we've discussed before. Derivative of the first one, 2 times 2 is 4. 2 minus 1 is 1. Keep the second one. Keep the first one. Oh, we need a plus sign. Don't forget that. Keep the first one. Keep the first one. We're going to keep the first one and derive the second one. Beautiful. Now, remember, what are we missing when we derive that y? I must include a dy dx. Beautiful. And in this situation, we're going to just go through it. So now we clean up. 0 is equal to 3 plus 4xy squared plus 4x squared y dy dx. Move everything that doesn't have an x over to the left side of the equation. -3 minus 4xy squared is equal to 4x squared y dy dx, and then divide by the coefficient of dy dx, which is be the number and the letters. And we finally get dy dx is equal to -3 minus 4xy squared all over 4x squared y. And if we had a specific point to plug it in, we would. We will cover that in another video where we go over more complicated implicit differentiations. This is just a basic show you how to do it, and this should be a little more clear. If you have any more questions and specific problems you would like me to do, please just send me an email. And yeah, hope everyone has a great day.